Looking at reading and writing of expressions. So we're going to do a couple different examples. And again, what is important throughout this is finding the key words, understanding what the problem is asking us to do, and then putting that into sort of a math form. So if we look at the first example, the cost of pizza is $12 plus a charge for extra toppings T. So one of the first things I see is that pizza is $12. It uses the word plus, so I'm automatically thinking addition, extra toppings, and then we have the variable that's given to us in the letter T. So I'm going to go ahead and put this together and say the cost of a pizza is $12 plus the charge for extra toppings, which is T. Okay. Let's look at a second example. A bus can hold 30 students. If S represents the number of buses, how many students can ride? So again, I'm just going to go through and think what's important in this statement. A bus can hold 30 students. So that automatically catches my mind. Okay, I might have a total of 30. Here I have my variable S. Represents the number of buses. How many students can ride total? So what I'm going to think of, let's change this problem to B. B makes more sense to me. B for buses. S stands for students. The number of buses, how many students can ride. So I know that however many buses I have, I'm going to multiply that number because a bus can hold 30 students. So I could write it like B. This dot is another way to write multiplication. B times 30. Or I could flip it around. This is kind of how we want to get to. We want to write our coefficient, that number in front, 30B. This means 30 times B. B stands for bus. So 30 students times however many buses I have. Again, in these, remember, expressions, we are interested in writing, creating the expression. We're not actually solving these problems, okay? I would need to know more information. I would need to know what's the price for an extra topping. How many buses are there? So I'm not able to get final answers, and that's okay. Sarah earns $8 per hour, H for babysitting, but she has to spend $4 to buy her bus ticket in order to get home. So again, let's think about what's important. $8 per hour. So automatically I'm thinking I might have multiple hours. So I may be thinking multiplication because I have $8 multiple times. And then she also has to spend. So now I'm thinking take away, spend $4 in order to get back home. So this may be multiple steps here. If I have $8 per hour and I work H hours, so let's say 8 multiplied by H, and then I have to spend $4 to get home. So I'm going to take away 4. So again, I'm just going to kind of combine this and say 8H minus 4. If I work 10 hours, I could plug in H for 10 and solve. If I worked 2 hours, I could plug in for H and solve. We're just creating the expression. A group of P students goes to the fair and 5 more students join them. The total group is then split into 3 equal teams. Okay, so let's say that our group of students, P, okay, so we have P number of students, go to the fair. 5 more, so that keyword more is probably telling me I'm going to add 5 more students join them. After that happens, the total group is split into 3 equal teams. When I hear split into 3 equal groups, 3 equal teams, 3 equal parts, I want to think division. So I'm going to take however many students I started with. We called them P. We're going to add 5 more students to that group. So that whole big, group of students is P plus 5. And then we're going to divide the entire group by 3. And remember, when we deal with fractions, we have sort of imaginary or invisible parentheses around the numerator and the denominator. So you could write it with the parentheses around it as well. We did 4 different examples. Some were 1 step, some might have had 2 steps, like these ones, examples 3 and 4. Some used addition and subtraction, some used multiplication and division.